When I was a kid, my grandfather came to visit. It was in the middle of the winter, February, I think. And when he arrived, I saw his car pull into the back of the driveway, and I came out to greet him. As two of us are walking across the driveway, he falls and he hits his hip and he fractures it. And I was surprised because it didn't seem like it was that bad of a fall to me. Well, here's what was going on. My grandfather was an older man, and as you age, you lose bone density. So you can see here, this is what a healthy bone looks like. Whereas someone who has osteoporosis, which means low bone density, you can see that there's not as much substance there, and that makes them susceptible to fracture or to breakage. So we're going to be looking at bone density today, and there's a little bit of information I need to fill you in on. The first is here. I've got my samples of human height document open. Bone density is measured on an unusual scale. What you get is a reading called a T-score. And here's what a T-score means. This is important. Make sure you get this. A T-score that is 0 represents having a normal amount of bone density for a young adult. That means that if you have a positive T-score, you have above average bone density for a young person. And if you have a negative T-score, you have below average bone density for a young person. But keep in mind that as we age, we lose bone density. So most older people are going to have these negative T-scores. The way that they are rated goes like this. If your bone density score, your T-score, is between a negative 2.5 and a negative 1, that is considered concerning. Whereas if it is negative 2.5 or below, you are diagnosed with osteoporosis. So what I have here are two groups that we're going to compare. The first column is young people's scores, and the second one is old people's scores. And the first thing that we're going to do is we're going to get our summary statistics, beginning with the sample size. The way you get the sample size is to do count from, let's see, this is A7, all the way down to A49. Now we can use that range. Just going to copy those for the rest of our column. So the mean would be average, that range, and then median of, oh, it gave me an interval, but that's not the interval I want, range. And then the mode on that range. There's our three measures of center. And then the mode says not applicable. That is because there are no two scores that are the same. Here we go, standard deviation, min, and max. Okay. Now I'm going to go ahead and do the same thing for the elderly scores. Now it'd be nice if we could just copy these and paste them right over here. The problem is that's not going to work. You probably know why. It's because the elderly group, there are a few more scores. This goes all the way down to B56. So one thing we can do is just systematically go through each one of these and change the second value to 56. Okay, so we've got our summary statistics. Another thing that I thought might be helpful for us to look at here, it's not always the case, but just find the proportion that have a concerning bone mass density, and the proportion that have osteoporosis. The way that you would do that is you would count the number that are in that range. For concerning, that's anything from -1 to -2.5. So that would be these scores right here. Hang on. A6 to, wait, no, I want to do, there we go. And then since we want the proportion, we're going to divide that by the sample size, which is 43. That gives me this number. And then 0 here, because no one has osteoporosis. For the elderly individuals, this would be count the number from -1, which is right there, up to 2.5. I actually want to take that number, that's a little big, and divide it by the sample size to get the percentage. All right, proportion with osteoporosis would be count down to there. Those are the ones that are smaller than 2.5, divided by the. All right, so let's look at these data. What do we get out of them? Well, you can see that the measures of center are much more negative for the elderly patients. And then you can see that the standard deviations or the spreads are relatively similar. All right, let's, I'm gonna get this out of the way. Let's look at some graphs. So when you're graphing, just a couple of principles here. I'm gonna do the youth first. And I'm gonna come over here. And then I'm going to change this to the histogram. And this looks like a pretty good histogram. It's moving by intervals of 0.75. I don't know if I'm in love with that. The other thing is when I'm done, I want to be able to line this up with the other histogram. And I know that the other histogram is going to go almost all the way to -4. So I'm going to change a couple of things. One thing I'm going to change is I just clicked on that horizontal axis. And I'm going to change the minimum to -4. And then the other thing that I'm going to do is I'm going to go here and I'm going to choose the bucket size. Let's go by a bucket size of 1. All right. So there's our youth scores. And then now we can do the elderly scores. Okay. Same game. Change this to. You can see that the interval is not what I would want it to be. Let's see, the other one goes from -4 to 2.5. So let's make this one also go from -4 to 2.5. And then I am going to once again change the bucket size so that it's exactly the same. All right, so we get these two that we can compare. What I did with these is I copied them and I pasted them into this document where I can see really clearly that the bone density score is on average lower for the elderly. I can see that they both have relatively symmetric distributions and that the spreads are pretty similar. So that when I'm writing this up, I would say something along the line of this. For the shape, we can say both the young and old distributions are relatively symmetric. Let me see if I can make my font bigger for you guys. Oh, that's much better. And then let's wrap these babies. And it's gonna move me. You scoot over. Okay, for the center, we would, let's see, use the mean. And so we can say that older people have less bone density on average. So there's the making meaning out of it. Because, I can type the whole word, I won't be that lazy. Their mean bone density, notice that I used the mean, I cited the statistic that I picked, is 1.77 points below young folks. Okay, and then as we're looking at the standard deviation, you can see that they're pretty close to each other. And so I would say in this case that the variation in bone density is roughly the same between young and old people because their standard deviations only differ by 0. What would that be? 1.4. I suppose you could also say that there is slightly more variation in the elderly people's scores.